Hello everyone, my name is Sagar. We belong to batch 4 and I'm going to discuss about the codes based on our project. I belong to the team consisting of me, Bhavna, Shivam and Poonam. We are working on the project of fraudulent detection or malpractice avoidance in examination hall. So as discussed prior by my teammates about the web-based implementation due to the present lockdown situations, which doesn't let us to doesn't allow us to implement it on a hardware, so we're planning to make the entire system go online. So one of our major ideas is to create a local host which would host our codes in the form of a web application, and all authorized peripheral devices would be allowed to access this local host. So we are planning to achieve this by implementing Django framework and using the Django server, which is provided by that framework. The rest of our codes, which are presently running, would be written in Python, which we'll be discussing in a few minutes from now. And let's begin with the code. So our codes is basically divided into 3 sections, and they look something like this. Just a minute. All right. Yes. So as you can see, this is our coding environment, and this is the first code. This code is supposed to run during the execution of our web-based application. So this is where the registration happens. This is the backend of the registration. So what particularly this particularly does is it creates a live stream video, as you can see by this particular piece of code, and it breaks down that particular video into smaller frames or photos of that particular person, whoever is registering themselves, and it then creates a data set, that is the name and all that, name, roll number and all that, which is picked up by the front end, and it stores it locally on our server in the form of a database. The databases will be discussed by Shivam Pandey and the front end is discussed by Bhavna. All right, moving on. The next procedure which we have to follow after getting the database, that is the images, we need to extract embeddings from the photos. This would be done by our code, which is embed.py. So this is a pretty basic code. What it does is, in the present environment, it first of all accepts a lot of arguments. For example, it accepts the database and the other model, that is the face detection model, and it gives an output file, that is the embeddings file. That is the main importance for us right now. So what we do is we import all the data sets. As you can see, the first few lines up to the line number 45, everything here till here is all the input part, and then our main computation part starts from here. So what we do is we store all the images in an enumeration, and then we try to read whatever image the pixel values of the image are, and we draw a contour on that particular face, okay, on that particular face, and then you see this image blob. So this particular section detects a face in a particular image. All right, and then what we do is we pass it through the detection framework. So this is particularly happening due to the predefined open face model which we are going to use. So what happens is everything is inbuilt. So we just detect the particular face by detecting using the VH method. We store it in an array which is known as box, and we give a particular name which was collected from the database to that particular face. This is the first particular code, and then in the end what happens is we embed these in a particular format in another array which is known as this embeddings. all right, and we write it to another file known as a pickle.dumps data file, which is used by our next model, which is the next code, which is the train model.py. Even this what this code does is it takes in a few arguments. For example, it takes in the output file which was generated by the embed.py, the previous code. It takes that as the input, and it gives another output which is the recognizer file. So this is going to run mainstream. When we are running the particular code live, that is going to recognize images, live video to be precise. So this is a pretty straightforward code. What we do is this code, it trains the model, and it actually teaches it or maps a particular facial feature to a particular name or a particular value which was pre-generated or predefined when during the registration section. So what it does is it just maps names to the data, this entire part, and then it gives another output file which is here, the recognizer.pickle file. This is the output file or the labeled embeddings file, because we call it as label because it's labeled, it's mapped, right? So the name and the data, whichever is generated, the embeddings are labeled in this particular file. That is the output, le.pickle file, that is labeled embeddings.pickle file. So this file serves as our real-time recognizer. So let's go to this recognize video.py. So this code is our main code. So this is what runs where the camera is. So what this code does is that it uses the output file which was given from the previous code, that is the train model.py, and that file which has all the values, all the embeddings stored with it, with the mappings. So it takes that in the first particular arguments. As you can see, we have the direct detector, the embedding model, the recognizer, the pickle file, that is a labeled pickle file, and a bit of confidence encoding, which we'll discuss later on. So what this does is, as you can see, from line number 50 onwards, 46 onwards, it starts a video, breaks it into frames, all right, breaks it into frames matching with the FPS of the camera, and then for every frame, whatever is generated, we have to try to detect it. So we have a detector which is set in line number 70. So this particular loop, while loop, from 55 onwards, from line number 53, 53 through line number 127. So this entire process is infinite, right? So whatever live video stream is given, we try to analyze it live. So what it does is it passes a confidence. Every image, whatever is detected, thanks to the previous files which were generated, it passes the confidence. So what happens when confidence is, that is actually the probability of the detected faces being true to the particular person. So we are trying to have a threshold probability, that is a confidence, a threshold type of thing. So if the confidence is very low, so what happens is, one advantage is that you have better predictions, better accuracy, but the precision comes down, that because you might not get that particular amount of correct predictions when the confidence is low. So the confidence should be set to a medium level. And the other thing which will be useful to increase the accuracy of this particular code would be to have a greater data set of every particular angle of the face. All right. So the beauty of this code is that we are not writing different codes to detect different facial features. Like the frontal face, there's a separate code. The side face is a separate code. It's not like that. It's just one code which runs on a machine learning model, which is embedded in OpenCV library. So you train it once, and it's going to run always. You don't have to write separate code to train different facial features. So this is the entire code. So what we're going to do is we're going to run, this is the idea. So this code is going to run on the browser, right? So as I mentioned earlier, it's going to be centralized because you can't use any hardware. So there's a lot of CS based, just a minute. Yes, there's a lot of CS based terminologies which is used here. So this is just the backend, the very basic backend of our uh, website, or a web app to be precise. So it's used in Django and it uses JSON data type. And this is our different files which we'll be using here. And we will be trying to get different views on the web app. Yes. Now continuing further. So the recognized video.py file is going to be run on the peripheral devices. The output file of the previous codes, whatever is given here, that is the pickle file and the labeled array files, will be provided to the recognized video.py file by the registering where the server which is going to be registering new users. So that is going to provide all the output files which will be necessary for the peripheral devices to understand what faces are going to be present in the live feed and how to recognize them. So our model, I'll just draw a brief diagram of it. Yes, so as you can see, this is going to be our rough diagram of the flow chart of how the things are going to work. So here presently in the server, which is the local host, as you can see here in the local host, this is where the main code runs. The registration, that is split.py, train.py, embed.py, is going to run over here. And then the local host is going to be constantly in touch with the peripheral devices which houses the camera modules. This can be any device which has a proper camera module and which is capable of running a browser on its terminal. So the advantage of this is that we don't have any bounds towards hardware. So the server should be most advanced in hardware because it's the one which is going to run the bulk of the code and which is going to be in continuous contact with all the peripheral devices. So the peripheral devices are just going to relay the output of the recognized video.py file. So that code is going to be run only on the peripheral devices. And in case if there is a mismatch or there is a malpractice which is detected in any of the peripheral devices, our framework will allow it to communicate with the server to alert it of this shortcoming. So every server, I mean, every contact or the connection between the server and the peripheral will be done via Wi-Fi for just for production, pre-production purposes to ensure all this, and this is going to be a secure connection between all the peripheral devices and the server. So by using this model, we can use this system on an online as well as an offline examination scenarios. Yes, thank you.